This thing here is called a political compass, and I created one for low-level programming mistakes to help you get unstuck, while talking to many beginners or intermediate programmers. And of course, knowing of my own mistakes, I managed to extract the common programmer behavior into two axes that keep many people stuck in their progress by doing too much or too little in either of these directions. So I will help you identify where you are so that you can start improving there. And stick till the end, because both axes are equally important. Let's go. The first axis is how much you spend learning versus how much time you spend practicing, but it has a little catch. We have a limited amount of time, so we can either work on a new project or study a new algorithm. Here is the thing, from my experience at least, many people lean into the learning too much category. And don't take me out of context, it is not something bad to learn new theory. But if you spend that time making a new big project, you will learn new things anyway. And not only that, but you will learn by practicing, and that is always superior to just reading about it or looking at an example given by an author. Things are always more complex in practice. And not only that, but many things, like algorithms for example, you will see that most of them you will rarely use. For the Minecraft clone of mine, I only used these very simple algorithms and data structures. It is made from scratch in C++, it is multiplayer, and I only used extremely basic things for it. Isn't that insane? On the other hand, it is also possible to do too much practicing and too little learning. I usually see this with high school people who are passionate about programming, but only do high school level coding. Okay, I know I like Minecraft clones, but this is another Minecraft clone I managed to make exactly when I finished high school, in C++ from scratch. If you compare it to what you learned in high school, it is laughable. But you can get here, and no matter where you are on this axis, here is what you have to do to not get stuck. Make sure you push your boundaries with more and more difficult projects. In this way, while practicing, you don't risk not learning new things, because you choose projects that are difficult. So you need to search for new things to finish them. You can quote me on this, always have a project going on that is just a little bigger than your current skill level. So for example, if you never made a game in C++, but you have C++ experience, and you want to make a game eventually, don't get stuck with high school level programming. Start making that C++ game. I know it sounds scary, but you are at the perfect level for that. And until you do this, you won't grow. I have many videos about this topic, and look at my channel's name, because it is dedicated to that. So subscribe if you're interested in this. And also, don't learn from a single teacher. Browse the web for new and more advanced topics, so you learn important things, like this epic YouTube channel that I always recommend. And whenever you find something new, unless you enjoy it a lot, don't just spend time reading about it. Do the hard thing and make a project with it, and then you will learn way more. Don't skip this part, because your boys got it. Before I reveal the second thing that keeps people stuck, if you are making a game right now and are in need of sound effects and music, you don't want to miss this offer. OvaniSound sponsored me with an exclusive extended Black Friday offer, where instead of paying $1,670, you only pay $19.99 for hundreds of sound effects and a ton of music pieces. I can guarantee that the quality is good. You get variations for the sounds and for the music, and all the sounds and music for this video are taken from this pack. So, link is in the description. Take a look if you are unsure if you'll get the sounds that you are looking for. But there are a ton of packs included, from retro to magic to guns to anime songs. And as someone who released a game on Steam, I can tell you that you need to spend good money if you want custom music and sound effects for your game. So it doesn't get better than this. And I'm not kidding when I say there are hundreds of sounds, so go check them out. And now, we get into the second axis, and it has to do with how you write your code. And the names I gave to the end of the axis might be misleading, but here is what I mean by that. There are people that are into things like OOP and design patterns and smart pointers and polymorphism, you get the idea. And I'm personally against that style of writing code, I'll tell you why. But those that aren't into these things aren't safe either, because they tend to get into premature optimization hell. So, if you don't like OOP and all the things I mentioned, here is what argument you can use against it. And if you like it, here is what I would say to you. There are many ways to write a piece of software, but once you write it, you can clearly see if it was very bad or good. While talking to beginners, I see many of them getting stuck because their codebase became too hard to maintain and need to start over. Here is the thing, OOP is not inherently bad, and the same can be said about design patterns or other things. Everything you do has a cost and a benefit, and nothing is a one-size-fits-all solution. So, if you just use OOP and design patterns in your projects, first of all, you won't get to see alternatives, and there will be many places where your style of coding doesn't really fit, and instead of solving the problem itself, you will struggle to make that problem fit into your design pattern box. If you do too many abstractions up front, the code will break down, Because 1. You try to do too many things at a time, and also because you can't possibly come up with a good abstraction from the beginning. You barely understand how the project is going to work. So this is what I recommend to you. Do approach-based design instead of thinking about any design pattern. Just start solving things one step at a time, and don't think about abstractions or smart pointers or anything. Just make that thing in the simplest way, and you can add the little abstractions or optimizations there if it is really easy to do. Then, while your project continues to grow, and while new things are added, and you understand more and more about how your systems really interact, you'll begin to understand what is a better way of adding abstractions over it. And that thing might even end up being OOP. And I have nothing against that, because it will be way better than if you were to just do an OOP hierarchy from the start, when you barely understood your project. I have my own style of writing code that is very good for making games from scratch in C++, but it might not be as good for something else. So, I'm not telling you to avoid abstractions, but to wait a little. Don't make too many things up front. And I know you are lazy and you don't want to refactor the code, but this will save you time actually. Because first of all, a lot of code won't need refactoring at all. Some systems, that you don't expect to, end up so simple and isolated that they don't need abstractions. So why waste time on that? And the code that needs refactoring is easy to refactor, because you wrote it very simply, and also because C++ being statically typed helps by giving you compile errors. And once you refactor it, it will be way better than if you were to write with abstraction from the beginning, because you know much more about how your systems interact. If you do it up front, you are just guessing. So let me give you an example. I see many people use smart pointers to store their resources and systems, but why allocate these things on the heap in the first place? Why don't you just put all the resources that your game always needs in a single place, and once you allocate them, never ever deallocate them? Or why not just put the systems on the stack? You might say that you may want to deallocate them to save memory, and you might have other excuses, but is that really true? Well, if you just put all the things on the stack, for many of them, you will soon realize that you didn't need to allocate them in the first place. Or for many resources, you will realize that you don't need to ever deallocate them if you need them for the entire duration of your game. There is no such thing as leaking resources after the program closes. So then, no wonder you don't need smart pointers if you don't allocate memory. I have a video on this topic, but that doesn't mean they don't have a use. For some systems, I actually might end up implementing a garbage collector, or using smart pointers, but they are clearly not the one answer as people say online. Okay, but now how can you possibly over-optimize things? Well, again, everything is a trade-off between a cost and a benefit, and optimizations aren't cost-free. Usually, they come at the expense of making the code way more rigid and hard to expand, but the cost can just be the time spent making them. I see many beginners being obsessed about saving on memory, and I don't know where this obsession comes from. Like, we have gigabytes of RAM, and here we are, trying to save on a few kilobytes, what the fuck? Oh no, but with that mentality, Chrome ended up taking so much RAM. Bro, you are making a 2D platformer, what are you talking about? You won't have a memory problem unless you start leaking stuff. The cases where you need to save memory are if you save a lot of memory, or if that memory savings makes a drastic improvement in performance. Like, you want to send that data to the GPU or through the network. Otherwise, if you have to spend time weirdly packing your data to consume less space, you might say it is something, but that won't make any difference. None. And for that zero difference, you are just wasting your time and making your program harder to change. As stated earlier, you want to be able to change your program to improve it. I also see many beginners doing micro-optimizations, like using bit shifts instead of dividing by 2 and other stuff like that. But things are not black and white here, so watch this video here if you want to improve more and understand when and what optimizations to do. See you!